This video shows an approach to using software engineering in the partner programming project in your course. First, we'll go through some definitions, like what software engineering is, and what the Scrum approach to software engineering that we're going to show you is. And we'll illustrate it with a pair of students creating a tic-tac-toe app through the software engineering process. Software engineering is defined here. It's the study and application of engineering to the design, development, and maintenance of software. The idea here is that creating software, although you can kind of get it to go quickly and have something fun and easy at first, good software, robust software that works all the time and can be sold commercially as a product takes good engineering. And particularly when you're working with a team, you need a process to ensure that the software development goes smoothly. Software engineering usually involves phases, such as the requirements phase, where you figure out what the software is going to do, usually with the customer. The design phase, where you design how the software is going to work. The implementation phase, where you code it and actually create software. The verification phase, where you test that the software meets the requirements. And then a maintenance phase, where you maintain the software. The two primary approaches to software engineering are the waterfall approach and the agile approach. In the waterfall approach, each phase is done entirely before you move on to the next phase. So all requirements are determined ahead of time. Once all requirements are determined, then the software is designed. Once the software is completely designed, it's programmed. Once it's completely programmed, it's tested, and once it's tested, it's done and goes into a maintenance phase. Agile programming doesn't require the completion of each stage. Instead, parts of the software are planned, then built, launched, tested to get feedback, and that feedback might change the overall design. So then it's replanned, more parts of the software is built, launched, feedback is determined, and the plan is changed. The big difference is that in waterfall, all requirements are done first, then all design, then all implementation. In Agile, part of the specification is done, and then something's built. Agile also has an aspect called rapid prototyping, where you put some software out there, and based on the software that's put out there, you might change the requirements once you see it working. The waterfall approach is typically used in places like the U.S. government and the military, where contracting drives that all requirements are done ahead of time. Although it's kind of an awkward approach in that it's really hard to do all requirements up front if you actually haven't seen the software run. So in places where large contracts don't require all specifications up front, they use the agile programming approach. And this approach is used in smaller companies and companies developing their own products, where they develop part of the product and then they'll build it, launch it, and see how it works. And they'll go into this kind of phase of developing parts of the product so that they have feedback as the product development goes along. In this video, we are recommending that you use in your course Agile programming. And we're going to use a form of Agile programming called Scrum. Scrum is a form of Agile software development. It's been around for over 15 years. There are formal online training courses that teams of software developers can go through to learn how to do Scrum. And there are even companies that will come in and teach software developers how to do the Scrum process. We're going to show you an adaptation of Scrum for the project in a course where two software developers are creating an app for a semester-long or a course-long project. Now, Scrum is designed for large teams of developers, so we're going to adapt it down to just 2 students or a small team of students using something like the Scrum process to get their app done for their course project. First, we're going to go through some definitions. The software specification in Scrum is called a product backlog. The product backlog says what the software is supposed to do, and it's made up of product backlog items, which are the features of the software that the team needs to produce. We're going to write our product backlog items, or PBIs, in a form of specification called a user story. A user story has this format. As a role, I want some goal so that there's some benefit. So you'll see in a moment that the first user story in our tic-tac-toe app is, as a user, I want to play tic-tac-toe so that we can determine a winner of the game. That's a user story. That's one user story. Software usually has multiple user stories. So for instance, if we want to add a feature to the tic-tac-toe game where as a user I can play against the computer instead of another player, that would be a separate user story. Maybe I want to add a user story so that we can keep a high score, or a user story so that we can have different levels of play. Each one of those will be a user story. All of those user stories together is a product backlog, and that specifies what the software should do. And again, we'll see an example in a moment. In the product backlog, the PBIs are prioritized. What features are really important? Which ones should be in the first release? So, the product backlog is a brainstorming of all the features, and then the development team prioritizes them, saying we're going to build this feature first, and this, then this. The process is run by something called Scrum meetings, where the developers and the customer and the managers get together and determine things like what user stories should be in the backlog and what their priorities should be. Another important part of the Scrum meeting is determining something called a sprint. Remember in Agile software development we said let's build something first so we can kind of get an idea how it works and then adjust. The thing we build is called a sprint. So we'll pick a couple of the user stories that we think are important and we'll build them. When the sprint is to be done is set in the product backlog. So we put a deadline that the sprint should be done in a week or 2 weeks. And what features should be in the sprint are determined at the Scrum meeting. As we go along, we keep a Scrum document which documents all this so that we share a list of the PBIs, the features that we want to get done. We share a list of deadlines and the tasks to get them done. We'll show you how to do this. In our example, we'll be using a shared Google Doc to keep the Scrum document. And once it's all done, then we'll have a final product. So I'm now going to take you through a full example of doing a tic-tac-toe app using this adopted Scrum process. So first let's look at a sample Scrum document. This is a Google Doc spreadsheet. If you're following this process, you should create a Google Doc spreadsheet that looks like this. There's a column for the sprint number. Remember, sprints are groupings of features that we're going to program at one time. Each PBI is given a number. Then there's a long or wide form here for putting the user story in. These will be the tasks that the programmers have to do to get this user story to work. And there'll be a status as to whether we've completed the task or not completed the task. So the first thing you want to do is set up a shared Google Doc that you and the members of your team, and if it's required by your instructor, also the instruction staff, can all look at and share. So you want a shared Google Doc spreadsheet that looks like this. Note too that we have two tabs down here. Now spreadsheet applications like Excel and Google Docs allow you to create multiple spreadsheets in one file and have them tabbed. So this is the backlog tab that we're showing here. We also have a tab where we keep the notes from our Scrum meetings so that all of the design is done in the backlog tab and all the notes from the Scrum meetings are put into the Scrum meeting tab. So at the very first Scrum meeting where the team is getting together deciding what software to build, they're going to create an initial backlog, and we see it here. So here's the Google Doc now with 5 user stories that we put in. Here's the first one. As a user, I can play standard 9-square tic-tac-toe against another user using a shared device, like a phone or an Android device, so that we can play the game and determine a winner. That's PBI 1, and there'll be some tasks listed for it eventually. At this first meeting, the team brainstormed and said, you know what? It'd be fun if we also had a league where different players played against each other and we kept track of who was in first place. So that branch of thinking generated some other user stories. As a user, I can play tic-tac-toe against other players in a league with a ranking of win-loss percentage. And then here, that in addition to just the ranking, they're keeping a roster of all the games played. And here, they are going to create a web page so that it's not just kept on the device like it is in the first few user stories, that there could be a web page where you could see the league ranking results. So you can see at this first Scrum meeting, the development team decided to take tic-tac-toe and make a basic two-player game, and then go in the direction of creating a league. We'll see in later Scrum meetings that the development team or the customers said, well, maybe the league isn't quite as important, maybe we want the ability to play against the computer or the CPU instead of just a two-player game. But at this first Scrum meeting, they haven't thought about that. And that's part of the Agile process, is that new ideas come up as you build. So here's an example of the first Scrum meeting and the 5 user stories that they put together. Once the backlog is created, at this first Scrum meeting, the users also determine what their first sprint is going to be. Recall that a sprint means that they're going to build something within a deadline that has one or more of the user stories in it. So here we see that they've determined a sprint is going to be due on October 7th. I think that's a week from the time in this example. So in the first week, they're going to do a sprint that only has one PBI in it, the first one. They want to build a simple two-player game. Notice these other user stories, are not in a sprint. So they're going to be done later. The team wants to first build a basic two-player game to get some idea of how hard it is and what other kind of features they might want to use. So the first sprint is determined as only the first user story. Now that PBI, or that user story, has been fleshed out into tasks that the team came up with. They're going to design a user interface. They're going to write some software so that the game board appears on the device. They'll handle the X event, which means that whoever's playing X has tapped the screen where they want the X to go. They'll write software to handle the O event. They'll write software to handle if one player has won. And they'll write some software to reset the game. So in order to get this user story done, they need to do these tasks. And so far at this first sprint meeting, nothing has been started. Now, as they meet to program, they'll start to fill in these as being complete as they do the tasks. So this is how the backlog is set up at the first meeting with a sprint, and the sprint is broken down into tasks. Finally, at that first Scrum meeting, they put some notes in the Scrum Notes tab. So recall that the Scrum Notes tab is the second tab. We've been looking at the Backlog tab in the shared Google Docs spreadsheet. But the Scrum Notes tab here shows that we had a Scrum meeting on October 1st where we made the original backlog and we set the first sprint as having only PBI 1, and it will be due a week later. After the first Scrum meeting, the developers will go off and start to do the tasks in the first sprint. We are going to recommend that you use an approach called pair programming. In fact, depending on the instructor for your course, the instructor may mandate that you use pair programming. In pair programming, one person sits at the keyboard while the other person comments. So the pair are programming together with only one person typing and the other person kind of watching and commenting while they type. Then the keyboardist and the commenter switch roles regularly, such as every 30 minutes. Now, it may seem counterintuitive. A lot of software development teams want to kind of rush into it and say, you go write the X event while I write the O event, and you over there go write the user interface for us. And we'll all come back together and put it together. It's been shown through numerous studies that having two people work together on one keyboard is faster and more efficient and creates better code than individuals working separately and trying to bring it together. The idea is that having to talk about it with your partner, having the partner check what you're doing, bouncing ideas off each other, and then coding as you go, produces better software. So over the week of the first sprint, the pair program team will get together and design the user interface, maybe on paper, or maybe if it's using App Inventor, you'll just use the App Inventor designer. And then they'll write some software together to draw the game board. So in this case, this student will probably be doing the programming while this student watches and comments, and they try and get the game board with the 9 squares to show. Then maybe they switch, and the other student programs the X event, where they write an event handler to handle the user whose turn is X, tapping the screen. they test that and get it to work, and then maybe they switch again, and the other student programs while they write the O event. So they're going to program the tasks of the first sprint together over that week that was allocated in the backlog for the sprint to occur. And every time they meet, they record their meeting date and what they did in the Scrum notes so that they can know what times they met and what tasks they completed, or at least partially completed. So those things all go into the Scrum notes in the Scrum document. Now at the second Scrum meeting, which might be a week later after that first Scrum meeting, they go through a process where, now that they've built some software, are there any other features or user stories that we want to add? Do we want to reprioritize the user stories or the PBIs? Are things more important now that we kind of understand some of the software we've built? If the sprint was completed, then what's our next sprint? What features should we build next? And then if we're building a sprint, we have to determine what features to put into the sprint, what's the due date for the sprint, and what are the tasks for each part of the sprint that has to get done. So at this meeting, we determine all these things, and then we update the Scrum document. We'll update the backlog, and we'll put some notes in for this from the second meeting. So I'll now go through an example of the second Scrum meeting where the developers of the Tic-Tac-Toe app have built the first user story, the simple two-player Tic-Tac-Toe app, got it finished, and are now ready to think about what new features do they want to put into the app. Do they want to go to the tournament that was originally specified, or do they want to do something else? And then they're going to determine their second sprint. So let's take a look at that. So we'll first look at how they're going to add user stories at this second Scrum meeting. So here we see the updated Scrum document. It shows that the first sprint was complete, so all the tasks are complete, and we've highlighted it to show that that task is complete. Also in the backlog we see the other 4 original user stories. But now the development team at this second Scrum meeting has decided that they want to add the ability for a single player to play against the computer. And so we see new user stories, 6, 7, 8, 9, 10, all the way through 18, where they have brainstormed how they want to be able to play against the computer. And you can see things like in number 6, they say, as a user I can play against another player as in PBI1 or against the CPU as X, with the CPU playing strict defense, which means it never lets you win because it always tries to block, and random placement if there isn't a block. So it's giving you some specification of how they want the CPU to play against them. Then they go on. As a user, I can play the game as in PBI 6, which means a basic CPU to play against, but now with levels. On hard, the CPU plays defense and random placement otherwise. On easy, the CPU plays defense, but randomly makes errors so that it's possible for the user to win. So that's another user story. And you can read through the other ones here as they have brainstormed how to enhance Tic-Tac-Toe to play as a CPU against the player. And there's random hard levels and random introduction of possible errors in the CPU so that the user can win. And so you can see that those user stories get up to 18 user stories that could be in the software. Now maybe at a third Scrum meeting they say, well, this was pretty easy, we're getting this done, maybe we should go to 3-dimensional Tic-Tac-Toe. So these are all kinds of part of the brainstorming process that once you've programmed something, new ideas come into your head. But this second meeting, they've added user stories to allow the CPU to play against the user. Now at this second Scrum meeting, after the backlog has been augmented with these new user stories, the development team reprioritizes what are the user stories that are most important to do in the next sprint or the next release. So let's see an example of how they use the Scrum document to reprioritize the user stories for their next sprint. In the current document, the next user stories go into setting up a tournament among 2 players playing against each other. But let's say that the development team, or often it's actually the customer if there's a customer involved, has come in and said, well, tournament isn't all that important. We need an app where a single user can play against the CPU. We like your ideas there. Those are going to become higher priority. So what the development team does at the Scrum meeting is that they reorganize this backlog so that the user stories having to do with user versus CPU are moved up in the backlog so that they are the next priority and will be the focus of the next sprints. To do that here in the shared Google Doc, whoever is maintaining the Google Doc on the team can simply select the 4 user stories that had to do with the tournament, cut them, and simply move them down in the spreadsheet to after the user stories having to do with playing against the CPU. So now we see that our backlog looks like here's the completed sprint of the simple game, but the next user stories have to do with playing against the CPU, and that as we scroll down, we see at the bottom of the backlog is the idea of adding a tournament. And in a future meeting, if they brainstorm the idea of 3-dimensional tic-tac-toe, they would prioritize it. Is that more important than a tournament? So maybe those user stories would go here, or is the tournament more important, in which case the 3D user stories would go down here. So in this example of using a shared Google spreadsheet, the order of the PBIs in the spreadsheet establishes the priority of those PBIs. Now notice the numbers stayed the same because we need the ability to refer to them. So the number of the PBI is not its priority. It's its position here in the backlog list that establishes its priority. So once again, the PBI number is simply to refer to it, and the position of the PBI in the list establishes its priority. So next in the second Scrum meeting, after we've added the user stories and reprioritized the backlog, we look to see if a sprint was completed. In our example, a sprint was completed. The development team got the basic tic-tac-toe app to work in the first week. So it's time to determine what the next sprint is going to be. The questions they have to ask are what PBIs go in the sprint. Is it just one user story? Or maybe it's a few of the high priority user stories that can go into the next sprint. What's the due date for that sprint? Is it a week from now? 2 weeks from now? And then what are the tasks? What are we actually going to have to build to make the functionality of that sprint work? So let's see an example of setting up the Scrum document to add the next sprint to the document. So here's the updated Scrum document showing the backlog. In the backlog, here's the first sprint that was done on October 7th, and we can see all the tasks are complete. They've reprioritized a little bit more in the backlog to move user story or PBI 12 up to second so they can group it with PBI 6. And these two, as you can see by them not being highlighted, they're white, are the next sprint. So basically the team has determined that they're going to write the CPU as X and the CPU as O in a very basic mode, and that will be their next release. And they've set a 2-week deadline on getting that done. So in 2 weeks they want to have the CPU be able to play either X or O in kind of a basic mode. They've also laid out the tasks. To do that, they have to do a UI design, for instance a button that says 1 player or 2 players, because 1 player is the new functionality and 2 player is the old. They have to write the CPU X routine so that the CPU can play X, playing strict defense with random placement if there isn't a block. And they have to integrate this with the 2-player mode so that they work together. Those tasks will complete PBI 6. But in the same sprint they're doing PBI 12. So they're also going to have to write a UI design button so the player can choose whether they want to play X against the CPU or O against the CPU, X being the one that goes first. And they have to write the CPU's O logic. So these tasks have to be done in 2 weeks to complete this sprint, which will then add another piece of functionality to the app. You can see over here they've annotated that they haven't started because they're here at the second Scrum meeting. They haven't started this sprint yet, so they're annotating here that those tasks haven't started yet. Once they finish this second Scrum meeting, as always, they have to update the Scrum document with notes saying what they did in this second Scrum meeting. So let's take a look at the updated Scrum meeting notes. To do that, we click on the second tab down here. It takes us to the Scrum meeting notes. You can see here's the first Scrum meeting where they designed the original backlog. Here are the two meetings where they met to do pair programming and actually get the first sprint done. And here's the result of the second Scrum meeting that we just went through. The backlog was extended with one player versus CPU by adding PBI 6 through 18. We reprioritized CPU play above tournament play, so we moved some BPIs around. And we established the second sprint, which is going to be PBI 6 and 12, and that's going to get done by October 21st. At this point, they could adjourn the Scrum meeting. Now, if they still have some time, say they're in a common class or lab together, maybe they start programming or pair programming on the first task. So going back to the backlog, the first task is to do the UI design for the one-player, two-player, like where does the button go and what's it look like. So they start after this second Scrum meeting, or maybe even part of the second Scrum meeting, they can start the development process of doing pair programming to address the tasks of the second sprint. Then, when the second sprint is done, they'll hold the third Scrum meeting, in which case, at that point, they'll either add some functionality or delete it from the backlog, they'll reprioritize, and they'll set up what the next sprint will be. And this process goes on until the project is complete. And through the duration, this Scrum document is a living, breathing document keeping track of where they are, where they're going, and also serves to kind of document the process when the final product is complete. This completes our description of one approach to do software development in the partner programming project of your course.